so I'm going to talk through this problem here. So my given is WV is equal to SQ. So there it is, sort of labeled on my diagram. So I'm going to find where that is, identify it as my given. Okay. Now my next statement says WQ equals WQ. How do you know something is equal to itself? That's always reflexive property. Okay, when I look at my next statement, WV minus WQ is equal to SQ minus WQ. Does that fit the structure of segment addition? Nope, it's the difference of two things equals the difference of two things. So more than likely you're going to take a starting equation, subtract similar values from each side. So if I have WV equals SQ, so I have that in statement 1, can I subtract WQ from one side and WQ from the other? Yeah, when I remove equals from equals, the remainders are equal is subtraction property. Okay, when I look at statement 4, WV minus WQ equals QV. Is that the structure of segment addition? Yes, let's test it and see. Here it says WV minus WQ is equal to QV. So is it the whole minus the part is equal to the other part? Yeah, so this is segment addition. And I confirm that SQ minus WQ, so SQ minus WQ is equal to SW, also segment addition. Okay, so my final statement is QV is equal to SW. Okay, so what I'm going to do is I'm going to go back and look. Is there some place where QV and SW occur earlier in my proof? There is. Are those set equal to the exact same things? Not exactly, so it's not transitive property. So instead, I probably need to come about it by substituting. So if I take my equation from step 3, what can I replace WV minus WQ with? Its equivalent is QV. And what can I replace SQ minus WQ with? Its equivalent SW. So replacing with the equivalent values is substitution only.